I had to.
All right, whenever Jesse Miller tells me I hope this works right, I know we are in for a good segment. We've got U of I Professor Jesse Miller here this morning. Sorry, I just had to call you out on that one.
That's fine, that's fine. No. I had an accident on the way over and I spilled some stuff, so I'm just hoping that nothing got mixed up in the process. So it's not going to explode. I know you like it when I explode stuff, but it's not going to explode. It's not going to startle you. It's not going to scare you. I know.
I'm glad no one in charge of our insurance ever listens when you're in town. All right,
at least
so
I haven't burnt a table yet.
Yes, I think is the key word. All right, so you've got a lot of solutions out here.
That's right. Now, I showed in the last segment the oscillating reaction,
right.
And that was kind of neat. Now, that was more of a thermodynamic process, and we're going to talk about more of a kinetic process here. And remember, I said thermodynamics is whether or not a reaction will go, and kinetics is how fast that reaction is going to go. So, in this case, instead of having competing reactions, we're just going to have a reaction that goes one way. And that's that iodine that we saw, the blue that we saw, is reacting with the iodine and the starch to give that blue color. And we're going to do that. But what we're going to do is, in here, I have differing amounts of the iodate solution. I have a very small amount in here, and I have a large amount in here. The rest of it I made up with water. So this is a 10% solution, and this is a 50% solution. And in here I have an equal amount of the starch solution. So we're going to add these all at once. And you should see successively longer and longer and longer. And you can actually, if we had a stopwatch, you would find that one of the reactions is twice as fast as the other reaction, and so on and so forth. And you could actually, if you measure correctly, and measure twice and cut once, you will, you can set a clock by it. I mean, it's pretty accurate. Now, what this had to do with anything is becoming it's fall. You got your fall colors.
Got my fall clothes on.
And because it's fall, the trees, why do they change colors, right? Now, we're going to do that a little bit more in depth, and I'm going to show chlorophyll and the pheophytins and things like that that's inside the leaves. But what triggers that, and what triggers that is sunlight, okay? And as long as the day is longer than the night, the reaction kind of stays on one direction. But once the autumnal equinox hits and the nights are actually longer than the days, then the reaction's able to go further, and then it triggers that tree. So we're going to see that sort of here with this. So this is where you guys get to help. Okay, so grab two of these. Okay, and we'll all at the same time dump these in and then kind of swirl. Okay, you ready?
Yep.
1, 2, 3. And then just kind of swirl here. And we'll see, all right, and should start here. There's one.
Okay.
And then the next one should be here. Boom. And boom. And come on. Boom. That one's a little slower. We didn't mix that one well. And then this one's going to take almost twice. This one's going to be twice as long as this one.
Wow.
Okay. And these were fairly close together because it was, 50, 40, 30, 20, 10.
Right.
But this one's going to be twice as long as this one.
It's just starting.
Right. So this one was twice as long as that one. This is twice as long as, this one, sorry. This one is twice as long as this one, and this is 40. This one is twice as long as this one.
Okay.
Okay, and these other two are intermediate similar. But as you can see that, it was dependent upon the amount that we put in. Almost linearly in this case.
Right.
And if you put twice as much, the time is twice as much. So that's why we call it an iodine clock, because these reactions, the kinetics, are at a certain rate.
Okay.
And they're going to be that way. You're not going to change that, except temperature will change it and things like that. So a little bit of the trees changing color does have to do with temperature, but it's mostly the sunlight.
Interesting.
Yeah, as we change from days being longer than the nights, and then we start going nights longer than the days, that triggers that reaction. It doesn't trigger reaction. What it does is it allows that reaction. It's constantly building up, but then once it gets dark, it doesn't. So it's trying and it's not making it, and finally it makes it over that hump, that starter hump that you have to get over, and then the reaction goes, and then the leaves change color. And we're going to talk more about leaves changing color here when they start changing color.
Okay, very cool.
Interesting.
I was kind of in awe by that.
I know, and I've noticed that the colors, just a side note, colors have stopped.
They've certainly slowed down. I don't know if it's stopped.
It's been on orange for a while.
Has it?
I've
Okay.
been keeping an eye on it.
It was going for a while. So yeah, about a half an hour. It really just depends on how long it takes me or how carefully I measure everything out.
Cool.
But yeah, in this case, it stopped at orange. Sometimes it stops on blue.
Very cool. All right, Jesse Miller, another wowzer this morning with your science
Nothing
segment.
exploding.
Nothing exploded, so I get a break. My heart gets a break. Today would have been a good day though, because we've got a heart doctor
I know,
here.
I know.
We could have done it all at once.
Could all have been thematic. That's right.
Jesse, thanks for joining us this morning. If you want to see this again, we will have it online at IllinoisHomepage.net. We'll be right back.